Welcome back to Calculus with Mr. Robeson. All right, so last time we learned the long way to take the derivative. Today, let's learn the short way. All right, so we're going to learn the derivative rules for a constant, the power rule, and if we take some guy to a power and multiply by a constant, we'll learn how to deal with that. We'll also take a look at the equation of a tangent line. All right, so the constant rule. So we don't just get to get these rules, we got to come up with the rule. So this is saying what's the derivative of a constant? So C is some constant, and we're saying that the derivative of it is equal to 0. We want to show that this is true. So let's take a look at our limit definition. So let's go h goes to 0 of f of x plus h. All right, so f of x plus h is just going to be c minus the derivative of our function. Again, this is our f of x in here. The derivative, so minus f of x, which is just c all over h. So before we take any limits, c minus c is 0. So we just get 0. And there's no h left to take limits, so that limit is 0. So that proves this statement. All right, so here's examples. Take the derivative of each function. So the derivative of y, we want y equals 7. What's its derivative? So one way we can write, really this is a practice of writing derivatives. So the derivative of y with respect to our variable x will be, well, the derivative of 7. 7's a constant. We get 0. F of x equals 0. What's its derivative? Well, f prime of x is how we write its derivative. And 0 is a constant, so its derivative will also be 0. S of t. All right, well, we got a different variable this time, but we'll still call it s prime of t. Now our constant is negative. Well, its derivative is still 0. All right. Here, the tricky part is k is not a variable, pi is not a variable, e is not a variable. X is our variable. So dy, derivative of y, if x is our variable, is equal to, well, that's a constant, that's a constant, that's a constant. This is all just going to be some constant. I have no idea what value it will take, but it will be some constant. And when we take its derivative, it will be 0. So something to remember here, that means if we have a constant function, the slope of the tangent line will also be 0. Okay? So find the derivative, h of x equals 2 pi. Again, we're really working on notation here. Pi is a constant, 3.14159, and so on. So 2 times that is 6.28 and some change. Derivative of that is just going to be 0. And the way we write the derivative of h is h prime. All right, the power rule. So we want to show that x to any power ends up just bringing down that power out front. See how it was n up here and it's n there? And we have one less power up there. All right, so we're going to use a little trick from Pascal's triangle. So let's take a look at the derivative here. So the derivative, we're going to use the limit definition. It's the limit as h goes to 0 of x plus h to the n minus x to the n all over h. So these are n's up here. This is h and h down here. All right. So to multiply this out, we would use Pascal's triangle. And we would get x to the n plus n times x to the n minus 1 plus some other term, right? But all these other terms are going to have, and this will have an h here too, sorry, I forgot the h. All the other terms will have h squared or more, all right? So h squared or more, and then we're going to have minus x to the n all over h. These x to the n's are going to cancel out. We can factor out an h from everybody because these guys all have h squared or more. So if we factor out that h, we're left with n times x to the n minus 1 plus some guys with h's all over h. And now these two h's are going to cancel each other out. And then with what's left inside, we take the limit as h goes to 0. And all these guys are going to have h's, so all these guys are going to go to 0 over here. And we're just going to be left with that part right there. So that is n x to the n minus 1. All right, so that's how we get that derivative rule. All right, so now the trick is to write things as x raised to a power. So this guy is x to the first. All right, so the derivative of x to the first, we bring down the 1. We've got x to the 1 less exponent. So 1 minus 1 is 0. And anything to the 0 power is just 1. So we just end up getting 1. So the derivative of x is just 1. If you want to learn that as another rule, that's fine. You can use that as a power rule as well. All right, here we got x to the third. So we bring down the 3 as a coefficient. So we get that f prime of x equals 3x to the 1 less exponent. So we're going to subtract 1 from 3. We get 2, 3x squared. All right, g of x equals the cubed root of x. All right, well, we want to write that as x to some exponent. So we can write that as x to the 1/3. That's how we write roots. It's 1 over whatever the root is. All right, so that means g prime is, well, we bring down the 1/3, and we have x to the 1 less exponent. So negative 2/3. We can leave it like that, or we can move stuff around. We usually don't like to keep negative exponents. So the 1's going to stay on top, the 3 is going to be on the bottom, and x to the 2/3 is going to move down to the bottom. We can rewrite that some more if we want. The 3 on the bottom is going to be the root. The 2 on the top will be the exponent. So we can say this is 1 over 3 times the third root of x squared, like that. We can also leave it like this. Either one's fine. We're just practicing simplifying roots. All right, and this last guy, 1 over x squared, we can write this as x to the negative 2. So then we take the derivative, dy dx is going to be, we bring down the negative 2. We've got x to the 1 less exponent. So we subtract 1 from negative 2, and that gives us negative 3. We can leave it like this if we want, or we can bring that negative 3, x to the negative third down to the bottom and just say this is x to the third. And there's our answer, negative 2 over x to the third. So we write it as a negative exponent. All right, so here's an example. What is the derivative of y equals x to the fourth? All right, if you need more time, go ahead and stop it. All right, so the derivative of y, we can write it either as y prime or as dy dx. Either one of those is acceptable. All right, here we're bringing down the 4, so the 4 comes down as our coefficient now. And we get x to the 1 less exponent. 4 minus 1 is 3. So we get 4x to the third. There it is, right there. 4x to the third. All right, so applications for this. So we can find our tangent lines just like we were doing before. We just had to take the derivative, and then we plug in, and that gives us our slope. So find the equation of the tangent line. So I mentioned earlier, tangent is a key word that tells us we're doing derivatives. So we want to take a derivative here. To the curve y equals x to the fifth when x equals 1. All right, so to find the equation of a line, we need a point and we need a slope. To get the point, we plug into the original. So our x value is 1, so we get 1 to the fifth equals 1. So we get the point 1, 1. So there's our point, 1, 1. To get the slope, well, we need a derivative. All right, so our slope is going to be equal to the derivative, dy dx, when x equals 1. So we take the derivative of x to the fifth. So the derivative equals, bring down the 5, 1 less exponent gives us 4. We plug in the 1, we get 5 times 1 to the fourth, or just 5. So our slope is 5. Now we're just going to use point slope form from algebra. It's y minus the y value equals the slope times x minus the x value. And there's our equation. We can leave it like that if we want. If we want to add the 1 over, we can do that. Like that. Either one of these is fine. You don't need to distribute this and simplify and combine like terms unless it's a multiple choice. Otherwise, you can leave it like either one of these on the free response, and that is considered a correct answer on the AP exam. So that works for my exams as well. All right, next up, find the equation of the tangent line. So another tangent line. So tangent means we're going to have to take a derivative to the function f of x equals x squared when x equals negative 2. So we got to do the same things. We need a point and we need a slope. All right, so to get the point we're plugging in, we want f of negative 2. So that's negative 2 squared. Negative 2 times negative 2 is 4. So we get negative 2, 4 as our point. To get our slope, we take the derivative. Derivative of 2x, we bring down the 2. 1 less power, 2 minus 1 is 1. So we get x to the first, or just x. And now we plug in the negative 2. F prime of negative 2 is 2 times negative 2 is negative 4. So our slope is negative 4. So now we just write it in point slope form. Y minus the y value up here is 4 equals the slope, negative 4, times x minus negative 2. So minus negative is going to change that to plus 2. 2 negatives make a positive. And there we go. There's our answer. If we want to move the 4 over, we can. But either one of those is correct. All right, so here's an example. Give this one a shot. If you need some time to do it, go ahead and just pause the video. Otherwise, we're just going to start working out the answer here. So we need a point, and we need a slope. All right, we want the equation of the tangent line, and that's what tells me we're going to do this. So again, tangent tells us that we want the derivative slope. That's how we're getting this slope. All right, the point, we want f of just negative 1. So that's negative 1 to the 6th. If it's an even power, it makes it positive. So we get the point negative 1, 1. For the slope, we got to take the derivative. So f prime of x, bring down the 6, x to the 1 less power. So 6 minus 1 is 5. Now we are going to plug in negative 1. So 6 times negative 1 to the 5th. To the odd power, it's still going to be negative. So this is going to give us negative 6. And that's going to be our slope. So now we write our equation. It's y minus this y value here equals our slope, negative 6. X minus negative, so it's going to be plus our x value. And there's our answer, which is exactly answer choice D. There it is. Hopefully you said D. All right, so one more thing for this lesson is constant multiple rule. So if we have times a constant, so if we have something with x's here, and it's all just times some sort of constant, this constant basically just comes out front. All right, so we end up with the constant times the derivative of the function with the x's, which just gives us c times f prime of x. All right, just like that. So the constant just comes out front. We don't worry about it. All right, the same is true if we're dividing by a constant. So this constant could have been like some sort of a fraction, like 1 over c. It would be the same thing. It would be 1 over c times f prime of x. Like if it was any sort of fraction, it would still be the same thing. So multiplying or dividing by a constant does not change anything. All right, so let's take a look at this guy. The first thing we want to do is write this in a nice form so we can take the derivative. So this x on the bottom, we're going to bring up and say that this is x to the negative 1. Now, we can just do a power rule with this constant out front. So the 2 stays. We're going to bring down the negative 1. X to the 1 less power. Negative 1 minus 1 gives us negative 2. All right, so negative 1 times negative 2 is negative 2. We get x to the negative 2, so I'm going to bring that down to the bottom and call that x squared. And we're done. There's our derivative. All right, I probably don't want to put an equal sign here. All right, that's not equal. This is when we start taking the derivative. So this is now dy dx. All right, so this is not equal to this. This is equal to the derivative of that. All right, so we don't want to put an equal sign there. That was my bad. All right, this one, we're dividing by a number. Well, we can write that as 4/5 times t squared. And now we can take the derivative of that. So then the derivative, f prime of t equals, bring down the 2. The 4/5 stays out front. We get 2t to the first. All right, so when we're multiplying a fraction by a whole number, we just multiply the top. So 2 times 4 is 8. So we get 8/5 t to the first, or just 8/5 t. All right, we're going to get a little more difficult here. First, we want to try and rewrite this. So this is 7 over 2, and this is going to be x to the, let's see, 2 over 3 on the bottom. So this is still on the bottom. So we can write this as 7/2 x to the negative 2/3 since it was on the bottom. Now we can take the derivative. So the derivative of y with respect to x is the constant stays out front. We bring down this new negative exponent, so negative 2/3 x to the 1 less exponent. 2/3 minus 1 or minus 3/3 gives us negative 2 minus 3 is negative 5/3. So let's see, the 2's are going to cancel out here. We'll get negative 7/3. This can move down to the bottom and become x to the positive 5/3. And we can rewrite that as the root. So the 3's on the bottom, so that means it's the third root of x to the 5th, like that. All right, last one here, number 4. There's a 2 inside. We got to get rid of that. So we need to distribute the 3 to everything down here. So if we distribute that, we get, I'm going to go this way with it, 5/2 to the 3rd, which is 8, and x to the 3rd. Now we want to rewrite that. We don't want x on the bottom, we want x on the top, or x on the side of it. So 5/8 times x to the negative 3rd. When we bring the x up, it becomes x to the negative 3rd. So now the derivative, which is g prime, because it was g was our original function, we bring down the negative 3. The 5/8 just stays. 5/8, negative 3, x to the 1 less exponent. So negative 3 minus 1 gives us negative 4. So negative 3 times the 5 is negative 15/8. X to the negative 4th moves down to the bottom and becomes x to the positive 4th. And there's our answer. All right, so you guys give this one a try. You probably want to rewrite it first with x to the 4th off the bottom. Then take the derivative and then try and simplify it, make it match an answer. If you need more time, go ahead and pause the video. I'm going to start working it out. So this is 3x to the negative 4. So we bring down the negative 4 when we take the derivative. So we get 3 times negative 4, x to the 1 less power. So negative 4 minus 1 is negative 5. 3 times negative 4 is negative 12. X to the negative 5th. I don't see that here. So let's see, we got negative 12 over x to the 5th. Hey, I see that. That's right there. So there's our answer. And that's it. All right. So that's a couple of the basic derivative rules. So we learned the derivative of a constant is 0. We learned the power rule is we just bring down the exponent. And we learned if we're multiplying by a constant, then we don't have to do anything special. We just leave the constant out front. And we looked at how to find the equation of the tangent line by finding a point and finding the slope.